over completing the square. We're going to do a little bit one with some right triangles and kind of like a word problem, even though I don't really go through word problems, so I'm not going to solve it, but I will at least help you set it up. We'll talk about just kind of like rational functions and end behavior and kind of like understanding that. And then we have solving a trigonometric equation on the interval 0 to 360. And then we'll talk about graphing exponential functions. And if you haven't already noticed, my voice sounds a little bit raspy. So yeah, I'm not at 100% right now. So we'll hopefully not going to go too long on the live stream. But if I do have some questions that I can answer after I'm gone through these that were submitted on my community post, then I'll be more than happy to do that for you guys. So please make sure if you do have some questions, feel free to go ahead and add them, guys, into the chat. If I can't get to them on this live stream, hopefully that other people inside the chat can at least help you out, answer your questions, or at least leave you to the right direction. So otherwise, guys, I look forward to another chat and another going to live stream. So to Alexander, Rosie, Mauricio, Brawl Time, good to see you. Is that Ice? Good to see you guys. And then Kaylee, Sarah, thank you guys so much for joining in. And wow, going in really fast. I can't even catch up and say everybody's names. So, this first question was tips and tricks, or at least a tip to kind of think about that. So, but yeah, so guys, hopefully I'm trying to get into the chat. Casey, thank you so much for the super chat. Can I go over the pinches and the inverse? I am not sure as far as on the pinches and the inverse. If you can maybe like rephrase, I don't have the terminology as far as the pinches, so I'm not 100% sure on that. If you can just make sure you maybe send that over to me. And either way, if you just want to put that back on the chat, I can privately go over this because I'm not going to be able to cover everything on the super chat. And I do also want to apologize. I did get a couple other super chats last live stream, which I really, really do appreciate. And I feel so bad that I wasn't able to call people out. I'm not sure what was going on with the stream, but my chat kept on going in and out. So I lost all that access to the chat, or to at least that super chat, to be able to see there. So I really do apologize for that. That was kind of one of those crazy things. But again, I do appreciate it, guys. But again, you don't have to super chat to be able to get your questions answered. I just want here to help you guys out, but I always do appreciate your guys' support and at least joining me on this Sunday evening to be able to do another live Q&A. So with that, let's go ahead and get started. And then, like I said, guys, if I finish a little bit earlier, I'll be happy to cover some open questions for you guys that maybe in the chat have not been answered. So the first one was just kind of like understanding completing the square. Is there any like kind of tips? So the best kind of tip I can really think about with this is, first of all, understanding what it means to go from standard form to vertex form, right? So we have y equals ax squared plus bx plus c, and we're going to convert this to, or we want to put it in this format, this a times x minus h, and we can see plus c. Let's just use a plus c here to keep things the same. Sometimes obviously we use k when we're talking about vertex form, but just to kind of so you can see, really the thing is we still have our a, right? But rather than writing this as an x squared plus bx, we're writing this as x squared or x minus h squared. And what that is, that's a binomial squared. So if we had like a fairly simple problem, like for instance, y equals, let's say, and again, I'm just going to do kind of like a basic idea here. If I had y equals x squared, let's see, plus 6x plus 9. Okay. Now, again, this is factorable. You can say that what two numbers multiply to give you 9, add to give me 6. You can see that's y equals, x plus 3 quantity squared. Well, what happened is I took a trinomial and I rewrote it as a binomial squared. That is technically completing the square. Like you creating a perfect square, you're creating a binomial squared. So obviously in this problem, it was very easy because we had a perfect square trinomial. But what if we don't? So I'm not going to cover the a because that's a little bit more advanced and just kind of a little bit more step. But my point that I want to do is like, what if we had y equals x squared plus 6x plus 10, right? So it's a little bit different. Now, the thing is, I know if I was going to be able to have this as x squared plus 6x plus 9, that would be a perfect square trinomial, right? Not 10. So what I can do is, well, what if I just rewrote that as plus 9? Well, again, that's cool. That creates my perfect square trinomial, which I needed. But again, don't forget there's a 10 there. And also don't forget, you just can't randomly add a 9 to an equation, right? Equations are equal on the left and the right. So if you're going to add a 9 to the left, to the right side, that's cool. But then you also have to subtract it on the other side. Now I can factor this down. And that becomes x plus 3 quantity squared. 10 minus 9 is going to be 1. And there you go. We have now converted from standard form to vertex form. So for a lot of the problems, the student was asking for like tips and tricks. A lot of the problems, it's going to be fairly easy. Obviously, there is like an algorithm that you can follow to complete the square for any quadratic, which is important. But a lot of students just kind of need like this idea of really what we're looking for. And then for the more difficult problems, you can kind of follow a more exact approach. All right, so for the next example, we basically have two right triangles inside of each other. And it was kind of funny. The reason why I typically don't do word problems, but the reason why I want to do a word problem like this is because right now, this is a chapter that we're doing in my class, applications of trigonometry, and we're doing a lot of word problems. And one of the things that comes up, the students just took a quiz, is they'll create a picture from the word problem, but then they'll just try to do the math. And, I think it's really important for students to really understand, like a lot of times, even when I taught geometry, students would still make this exact same mistake is, not having a hard time of like dissecting what information you have. So based on the word problem, this is the information the student had. We have an angle of elevation of 20 degrees, another angle of elevation of 15 degrees. And then these 2 points, which I think were observers, were like 100 feet apart or meters or whatever. And basically you want to find out the height. So the important thing here, and actually we don't even know this is x, but this is what I was doing in my head just to make sure that there was nothing crazy going on. We basically have like two triangles, and this is what I wanted just to help the student out with. So we have this one triangle. Here's like 15 degrees. We know this is a right angle. Here's h. Now we know from like here to here, we're going to say is like 100, but we don't know this distance from here to here, right? So let's go and look at the other triangle. Well, the other triangle has 20 degrees, and this is h. But again, in this case, we don't know what the side length is. So what we're going to do is we're just going to call this like x. And actually, let me just redraw the triangle like down here. Therefore, they're right next to each other. So then this is going to be represented as 100 plus x. Okay, now this is important because even though now I have two variables, right? But the important thing is, just like a system of equations, if you have two variables and you have two equations, you can solve. In this case, we have two variables and two triangles. So I can create a separate triangle for each one. So in this case, I'm going to do the tangent of 20 degrees equals opposite over adjacent. And then this one, I'm going to have tangent of 15 degrees. And that is going to equal opposite over adjacent. Okay, so now you can see that they both have the variable h. I can go ahead and solve. So I can say h is equal to x times the tangent of 20 degrees. And here we can say h is equal to 100 plus x times the tangent. Let's go ahead and close that. Put that back up there. Tangent of 15 degrees. There you go. Okay, so now since they're both equal to x, I can now set them equal to each other and solve for x, right? So that's the power of being able to have these two variables here. So it's basically like another system here, right? We have them both set equal to h. So now I can set them equal to each other and go ahead and solve for x. You can evaluate using a calculator, which I don't have with me. So therefore, that's why I'm just going to leave it here. You could distribute here. So you'd have 100 times the tangent of 15 degrees plus x times the tangent of 15 degrees, right? So you're going to distribute that. Basically, what you'd want to do is get those x's to the same side, and then go ahead and you can combine them and go ahead and solve for x. Then once you have x, you can plug in that equation and then plug it back. Or once you have x, plug it into that equation, and then you can go and solve. So it's a good question. And it's one that, a lot of students struggle with because you're having those two variables. All right, so the next one is understanding like the end behavior for, rational functions. So I'm just going to do kind of a little bit of like a calculus approach, or not really a calculus approach, but just kind of one that's just kind of gets into the idea of like something that we'd want to get into a little bit of the higher end is just understanding how, graphs grow, right? So, if you just think about numbers, for instance, if I had like x squared, right? So if I keep on plugging numbers in for x, they're going to keep on getting larger and larger, right? And again, when we're thinking about numbers, let's just pick 1, 2, 3, 4. Okay. So if this is my function x squared, and if I plug in 1, plug in 2, plug in 3, plug in 4, you can see those numbers are going to keep on going larger and larger and larger. So that's why, like if these represent my x values and these represent the y values, right? Like y equals, then you can see that as x gets larger and larger, the y value is going to get larger and larger, right? So as x is approaching infinity, you can say y is approaching infinity, or that m behavior as x is going to the right, you can see that y is going to infinity. So let's go and take that a little bit further and say, all right, why don't we just go ahead and take a look at some examples here. So what if I had x squared over x plus 1? All right. So think about this. If you keep on plugging in numbers, and for instance, let's get up to like 3. If I plug in 3, that's going to be 9 divided by 4, right? And then if I do 4, that's going to be 16 divided by 5. And so what happens is this top is growing faster than the denominator. So since it's growing faster in the numerator than the denominator, as x keeps on getting larger and larger, you can see that this graph is going to keep on getting larger and larger. So even though it's a rational function, since the numerator is growing faster than the denominator, that's why the end behavior is going to be going up to infinity. Now, this is where I'm going to kind of end. I'm not going to get too much calculus. I'm just going to focus on polynomials. How do we know if a polynomial is growing faster in the numerator and denominator? Well, for polynomials, we're just going to look at the degree. So obviously, calculus, we get into a lot more advanced types of functions, and we kind of talk about their growth. But for here, we'll just kind of stick with polynomials. If the degree in the numerator is larger than the degree in the denominator, we know that the numerator is going to be growing faster. Well, what about, let's flip it over. What about if the degree in the numerator is smaller than the degree in the denominator? Well, that means the value in the denominator is growing faster, right? Now, what happens when you have numbers in the denominator keeps on getting larger and larger? Like for instance, let's, if I had, 1/2, 1/3, 1/4, right? 1/5. And again, just imagine if those numbers are being squared, like they're going to get smaller and smaller and smaller. So therefore what happens is as my denominator is getting larger and larger and larger, what's happening is my end behavior is approaching 0. So I'll just write this as x approaches infinity, y approaches infinity. And as x approaches infinity here, y approaches infinity. I'm sorry, y approaches 0, right? So as we keep on getting numbers getting larger and larger and larger in the denominator, that's actually going to be approaching 0. So again, whenever the degree is larger in the numerator than the denominator, we're going to be approaching 0. And then the last example that we talked about is what about if they're actually the same? What if this was x squared plus 1 over x squared? Okay, what actually would happen here, right? And really, if you just keep on plugging in the numbers, like for instance, 4, right? That's going to be 17 over 6. And then you're going to have, you'd have, let's do 3. So it'd be 10 over 9. And then it'd be 17 over 6. And you keep on getting larger and larger and larger numbers. They're almost going to be exactly the division product, like the division of themselves as they keeps on getting larger and larger. So when you have the degree equal to each other, they're going to be approaching 1. So therefore, as x approaches infinity, y is going to approach 1. Now, why is it 1? Well, that is the leading coefficient of the numerator over the leading coefficient of the denominator. So really, the answer to my question, the answer to the student's question is identifying end behavior would just really be, especially if dealing with polynomials, is really just to find the horizontal asymptote. Obviously, for the first two questions, you have the horizontal asymptote. If 0 or in 1, In the first example, there is no horizontal asymptote. So therefore, you just want to be able to determine, is this numerator going to be going positive, or is it like negative, right? Where it's actually going to be going to negative infinity. So not getting super advanced because they always kind of told me to talk about it. So I'm not really sure exactly where they're maybe having trouble, but hopefully this kind of quick little overview kind of gave you a little bit of insight from there. All right, let's go ahead and get on the next question, which was solving trigonometric equations. So again, a lot of students, happens every year, they have trouble solving and they start making mistakes with inverse operations. So one thing, I reminded my students again this year was we practiced all of these. 4x squared minus 1 equals 0. Like, what would you do if you're in algebra 1 and algebra 2? Well, you're going to isolate your variable, right? And you're going to isolate your variable either by inverse operations or by factoring. And this one you could actually do by factoring if you wanted to, but most students usually don't look at factoring first. They usually look at factoring last. And so as long as we can apply inverse operations and we're not faking or making anything up, then typically inverse operations a lot of times are going to be an easy solution. Again, you can usually use inverse operations, or you can use inverse operations when you only have one variable here, in this case, x. So therefore, this is going to be plus or minus, let's see, that's going to be the square root of 1 over 4. Uh-oh. Now, it is very, very important that you recognize this, that again, this can be broken down into plus or minus the square root of 1 over the square root of 4. Now I'm getting into myself, which can be broken down into plus or minus 1 over 2. Okay? I don't know why. All right, whatever. I was thinking the answer in my head was something else. So either way, that's the exact same idea we want to do with trigonometric equations. We want to isolate our trigonometric function either by inverse operations, typically if there's one, or by factoring if there's going to be typically more than one. But hopefully you recognize the same operation here. So it doesn't matter if it is with, the x or with trigonometric functions. Now, the one thing that usually some students do, that some students do have trouble with is, sine squared of theta. Remember, that's just equal to sine of theta quantity squared. Okay, so that's just our notation. So therefore, it is sine of theta squared, just like x is squared. So therefore, we are going to want to take the square root. So therefore, we have sine of theta is equal to plus or minus 1/2, right? I already kind of did the breakdown for you. So now we need to understand all right, we need to find all the values that make this equation true. And we're just going to find them on the unit circle. Between 0 and 360 is basically the unit circle. So what I'm going to do is I'm just going to sketch the graph of the unit circle. And I'm going to say, all right, since I know my unit circle so well, I need to find all the values when sine of theta is plus or minus 1/2. So the easiest way to do this is to look at the first quadrant, because if you know the angle in the first quadrant when sine of theta is equal to 1/2, which is right there, which is pi over 6, then all the other angles that are going to have sine of theta equal 1/2 are going to have the same reference angle of pi over 6, meaning they're going to be pi over 6 away from the x-axis. So that's going to be over there. That's going to be over there. And that's going to be over there. Now, since these angles need to be positive and between 0 and 360, I'm just going to say, all right, well, if halfway around the circle is pi, but I'm pi over 6 short, pi is 6 pi over 6. So therefore, we could say, let's do a solution set here. So I'll say pi over 6. Halfway around the circle is 6 pi over 6, which would be pi, minus pi over 6. So that's going to be 5 pi over 6. Halfway around the circle is pi, or 6 pi over 6, plus pi over 6. So that's going to be 7 pi over 6. And then all the way around the circle is 2 pi, which is equivalent to 12 pi over 6, but minus pi over 6 away, that's going to give us 11 pi over 6. All right, and the last example was just graph exponential functions. They didn't give me an example, so I'll just kind of do a quick little overview on the graph. I'm not sure if they were talking about graphing via table or transformations. Really the main thing, guys, it doesn't matter if it's y equals 2 to the x, y equals e to the x. You just need to know the parent function. of the exponential equation. So now obviously these are not the exact same graph. They do obviously have a different growth, but their graphs are going to look very, very similar to each other. And then really the main thing that is, I think, most important about graphing a exponential function is that one, you're going to have the y-intercept at 0, 1. And then also you have this horizontal asymptote at y equals 0. So if you kind of remember those two characteristics, as well as what the graph looks like, obviously, that's really going to, kind of be I think the main thing that I want students to be able to take away as far as the exponential graph. Because from there, at least in our pre-calculus class and calculus, when we do exponential equations, we really just want them to know those characteristics and then basically how to apply, when we have transformations. So let's just say, let's call this B to the, we don't want to use B. Oh, it's been a while. What do we use? Oh, I'll just use E, I guess. Yeah, I'll use E. That's a good one. E, because really you could have anything being there. And then this would be B times X minus C plus D. Okay, so again, now all you're simply going to do is remember A is going to be your vertical stretch or compression, as well as a reflection about the y-axis. D is shifting up and down. Remember, A and D are your vertical transformations. A is multiplication, so that's stretch and compress, as well as reflect. And then D is your adding, that's why you're up and down. Inside of the function is going to be your B and C. So B is going to be your horizontal stretch or compression, as well as a reflection about the y-axis. And C is going to be your shift left and right. So basically, when you have an exponential function that you need to graph, my advice is to always graph the parent function first and then apply the transformations. And really, you're just going to apply the transformations knowing you have the y-intercept at 0, 1, and then the horizontal asymptote at y equals 0. So you just basically kind of move those points around, obviously the shape of the graph, apply reflections, and so on and so forth. So hopefully that is helpful for you guys. That is at least the questions that I had. And again, guys, if you would like to have some questions for my next live stream, then I would just make sure that when you guys are submitting questions, a lot of people gave me some problems tonight that I didn't know what they wanted me to do. They just gave me an equation. So I'm assuming things, but I don't really want to spend my time assuming something and get it completely wrong. So just make sure you're being detailed as far as what you'd like me to cover. Either the problem or either the topic, and then I'll be more than happy to try to explain what it is I can exactly, cover or answer. But, a lot of times I'll put these, I put the community chat all as soon as on Saturday. But a lot of times I won't even get to it until 30 minutes or an hour before the stream. So therefore we just don't have a time for a lot of that back and forth and for me to understand. So if it's not something that I can answer right then or understand what to do, then unfortunately I have to move on to another question. So, but either way, guys, the questions have been really good. I really do appreciate you guys submitting them, as well as joining me for these live chats. It has been a fun ride so far, and I'm not sure why my chat is slowing down. I think there. There we go. Yeah, my chat, I think it's just this bit rate is going. I think my bit rate is really slowing down on my live streams, but now things has been going out there. So, all right. So Francisco, was it awesome as I was hoping to be? I do appreciate you got there early. I have no idea what about any chemistry questions. Look at the super chats. All right, Mr. Beast. I'll see what. I'm sorry I missed you on your super chat. I'll try to get back into that. And I can't remember. Oh, geez. What do we have here? Man, okay. Coming through. All right, Mr. Beast. I know you have been supporting my channel. I really do appreciate it. I'm not seeing your super chat though. And I apologize. I didn't see it. Usually a lot of times the super chat will catch my eye. There you are. I need help with adding. I'm not sure what those are for able to do that. So I do not know what I can do. for you. So, Mr. Beast, feel free, just if you have something, if you want to reach out to me, send me a message on Facebook, or you can obviously submit me a thing on the super chat. I always do kind of go back to the live stream chats, and I do appreciate it. So K-Pasa was one that gave me a super chat last night. So thank you so much, K-Pasa. I really do appreciate your super chat. You gave me a super chat last time, and I didn't give you a shout out. So I do apologize for that, but I do appreciate you joining me back again for the super chat, and therefore this time I can give you at least a proper shout out. So I do appreciate that. Thank you again so much. All right. Let's see if we can get into the end. How much time we got? We got a little bit. I'll kind of see our gains. Law of cosines, please. I can do a lot of cosines. The only problem is I just don't have my calculator to be able to set it up. I can kind of like talk about the law of cosines though. There's really kind of one thing I just want to make sure, because there's a lot of older videos that I wasn't really prepared with the law of cosines. So, actually, we just covered this recently in my class. And so, really the main thing is, let's just kind of cover the two formulas. A squared equals B squared plus C squared minus 2 times B times C times the cosine of A, and then cosine of A equals B squared plus C squared minus A squared all over 2 times B times C. Okay, so just real quick, this is the exact same formula. It's just written in two different ways. Typically, we want to use the formula written like this when we want to be able to find our measure A. And typically our length A, and typically we want to be able to use a triangle like this, or when we want to find the angle, we're going to use this equation. Now, there's basically two types of times we're going to be using the law of cosines. That is going to be side, 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 when we have all the measures of the angles, or the side lengths. I'm starting to lose my mind. As well as when we have side, let's call this angle side. Okay. And the reason why we want to use law of cosines in this case is because we don't have a ratio, right? If we have a ratio, we can use the law of sines. So that's the nice thing about the law of cosines, is it allows us to find a missing measure without using the law of sines. The other benefit of using the law of cosines is we don't have to worry about the ambiguous case. And if you've covered the law of sines, you know that that can be a very, very confusing topic. And I'm not going to touch on it now because I only want to just kind of cover some topics quickly. But the law of cosine, or the law of sines in the ambiguous case, can be a difficult thing for students to be able to understand, as well as it takes a little bit more time to work on. So one thing I didn't stress enough on my earlier years of teaching was just having students do the law of cosines for all the time. Now, obviously, you can avoid using the law of cosines when you have side, 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 because if you find, like, for instance, let's find B, right? Or if you wanted to find cosine of B, and let's say B is the largest angle inside of this triangle. Well, if big B is the largest angle inside of this triangle, then you know that the side length B is going to be the largest side. And I'm sorry, I'm saying that the wrong other way around. If side length B is the largest side, then you know angle B is going to be your largest angle. So the nice thing about that is, remember the ambiguous case, you don't know if your angle is acute or obtuse. So if you use the law of cosines to find the largest angle always, then you can go ahead and use law of sines after that, because you don't have to worry about the ambiguous case. The problem with that is that's the way I used to teach it, but then I wouldn't really stress it, because when we get a side angle side, there's no way for you to make sure that you don't have an obtuse triangle. So therefore, what you need to do in this case is just always use the law of cosines. So the best bet is, obviously you're doing the formula. Here are the two types of triangles you're going to want to use to find the law of cosines. You don't have to worry about the ambiguous case, but to make sure that you don't make that mistake, my recommendation would just be use the law of sines. And if you understand it more, then yeah, use the law of sines when it's applicable. Otherwise, though, for most students, it'll just be a safer bet to continue using the law of cosines. Oh, all right, now come in the questions. All right. Jeez. One average person, I will give that as a 4. I've done a rational expression, so I'll go ahead and do that. Let's see what else we got here. Graph the function. That does not look fun at all, but I'll go ahead and do that. All right, now we're just getting crazy questions. I'm not going to be able to do the piecewise function. Find the total surface area of a cube whose volume is in cubic units. So I'm believing you just be taking the cube, but I'm not really fully understanding that from on there. And I'm not going to be able to explain x to the... Yeah, sorry, I'm not really seeing it, but no, I'm not really fully understanding the questions. All right, guys. Then I have a lot on trigonometric functions, graphing. I just kind of want to do this just because nobody would want to do this anyways. But like typically, if you're going to graph this, you're just going to graph this using a graphing calculator. But like, what if you have to go ahead and graph this? Then what would you do? So we can kind of look at that example. And what I'll do is I'll just kind of go over a quick little thing, although it's going to be completing the square. So actually that's fine. That'll tie us back into the completing the square. So I like that. That's good. So let me do this rational functions one, and then I will tie ourselves into the completing the square. 2x squared minus 16 over x squared minus 4 minus x plus 4 divided by x plus 2. Whew. All right. So I'm going to go and complete these, guys. I'm not going to be able to get to everybody's questions, guys. I usually only go for my 30 minutes. So I'm just going to cover these next 2 examples and just explain that. I do apologize, guys. But again, if you have questions and you want me to get them answered, I put a community post on Saturdays. You have from Saturday to Sunday to post any questions on there. And then I will, I always read every single comment I get. So, just make sure you respond, put them on there. And then, obviously I always like to check on Saturday as well as like try to get them on Sunday. So if I can't answer your question on the live stream, hopefully I can, give you at least a piece of advice to be able to what to do to solve the question or at least where to kind of look. So, but again, if you guys, anybody can help anybody as far as getting started with their problems on the chat, feel free to help each other out, guys. I do appreciate you guys doing that for each other, but I'm just going to finish up on these 2 questions. So the first one looks like we're going to be solving we're going to be subtracting. And one thing I recognize is that 2x squared minus 16. Well, that doesn't seem as nice. So this looks like a difference of 2 squares, but it's not a difference of 2 squares. This is a difference of 2 squares. This can be factored into a x minus 2 times an x plus 2. Okay, so over here, I already have x plus 2. So what I'm going to do, so I'm just going to delete that out. I'm going to multiply this by an x minus 2 times an x minus 2. Okay, so now this left-hand side is going to remain the same. So that's going to be 2x squared minus 16. Now you can see they actually have common denominator. So let's actually just subtract them here. Now, again, remember, you're multiplying x minus 2 times the quantity x plus 4. So I'm going to put that in parentheses here. And actually what I'm going to do is I'm going to put this in brackets. Okay, and that's going to be all over my common denominator of really, let's write this as x minus 2 times x plus 2. All right, so let's multiply this x squared. Let's do this to the side. X plus 4 times x minus 2. That's going to be x squared. That's going to be 4 plus 2x. Oh, jeez. So that's going to be 4x, and then that's going to be a negative 2x. So that's going to be a plus of 2x, and that's going to be minus 8. All right, so So we'll have 2x squared, and then you're going to minus 16, and that's going to be a minus x squared minus 2x plus 8. So what I'm doing is I'm distributing this negative to each one of these three terms. All right, so that's why that becomes a negative x squared minus 2x and plus 8. So I'm kind of shortening my work here a little bit just for the sake of time. So I'm sorry if this is an introductory video for you. And now I'm just going to combine like terms on my numerator. So therefore, this would be a x squared, nothing to combine with a negative 2x, and then minus 8, all over a x minus 2 and an x plus 2. Now, I left this in factored form, and the reason why I left this in factored form is I want to see, is this factorable, right? Can I break this down? Can I factor x minus 8 times x minus, what two numbers multiply to give you negative 8, but then add to give you a negative 2? Well, it kind of looks like I can factor this as x minus 4 times x plus 2. And what's important about this is you guys can see that this x minus 2 and the x plus 2, those are actually going to divide out. So therefore, my final answer, which we're kind of running out of space here, is going to be x minus 4 all over x minus 2. So I'm actually just going to box that. Okay, everything's all messed up. It's going left to right, blah, blah, blah. All right, so let's kind of go back to the original question, or the first question, not the original question, but the first question I talked about in this live stream, which was completing the square. And the way I talked about completing the square was going from vertex form to, standard form to vertex form. And we did that by creating a perfect square trinomial. Now, a perfect square trinomial, again, is a trinomial that can be squared into a binomial squared. And so therefore, obviously, if we have one, then we can just go ahead and factor it. If we don't have one, then we have to create a perfect square trinomial. So in this case, since we knew x squared plus 5x plus 9 was a perfect square trinomial, I just added a 9. But we recalled you just can't randomly add a 9. If you're going to add a 9, you're going to have to subtract a 9. But then you can go ahead and go about your business. Now, typically, if I had to graph something in standard form, I would look into, if I just needed to like sketch a graph, I typically would look to see if I could find the zeros, the x-intercepts, and then I'd just kind of look at the behavior of the graph. Is it opening up or opening down? So if you knew the graph was, for instance, if I had y equals x squared minus 5x, let's just say, minus 6. So if I had to graph this equation, I would just factor it. And I'd say x minus 6 times x plus 1. The graph is going to open up because the x squared is positive. So I'd say here's 6, negative 1. So the graph's going to look something like that. And typically for most applications, that's really what we need. Sometimes it's going to be helpful though to find the vertex, right? Or the minimum value. So that's where we kind of come into a problem with this function or this equation, is because we can't really complete the square. This does not produce nicely produce a perfect square trinomial. So if you look at all the perfect square trinomials, we're not going to have 5. So therefore, in this case, what we're going to want to do is follow the algorithm to be able to create a perfect square trinomial. And to do that, all you need to do is take your middle term, divide it by 2, and square it. So in this case, we're going to take a negative 5 divided by 2 squared, which is equal 25 fourths. So that is the number that completes the square. It's just like the number 9 that completed our square in our first example. So what I'm going to do is I'm going to take y equals x squared minus 5x plus 25 fourths. But again, you just can't randomly add a number to an equation. You're going to have to subtract 25 fourths, and then you're going to have to add 3, right? Because the 3 is still there. Now, remember, you've now created a perfect square trinomial, which can now be factored into a binomial squared. The factored form of this is where students usually have trouble, though, is just going to be this b divided by 2. So all you're going to do is do x minus 5 halves, quantity squared. And then this one, let's go ahead and let's do this work here on the side, because a lot of students do not like fractions. So we want to make sure we understand that. So let's multiply by 4 over 4. That's going to be 12. So this will be a negative 13 over 4. All right, so negative 13 over 4. So again, we still need to graph this, right? Now, the nice thing about this, having in vertex form, is we know our vertex here is 5/2, and our y-coordinate is going to be 13/4. So you can see why when I originally looked at this problem, like, why would you want to graph this? Because this isn't going to be anything nice. Like, I'm not going to give you a nice sketch of the graph of what this graph would look like. The important thing is understanding maybe the vertex, the shape of the graph. It's not like a nice it doesn't have nice intercepts. But you know, we can estimate here. So if I was going to estimate, that's going to be what? That's going to be like 2.5. And this one, 4 goes into there. So that's going to be 3 times, so 3.25. So I'll just go ahead and sketch that. So x coordinate is 1, 2. So 2.5, and then up 1, 2, 3. So something like this. And then again, the graph is going to open up. So there you go. You can see that it doesn't have any x-intercepts. So that's why this method wouldn't have helped us out. You could also create a table and just plug in numbers. Typically when doing that, though, you want to find the axis of symmetry first. But yeah, I wanted to kind of tie together with the completing the square. So thank you so much, guys, for joining. I do apologize. I know a lot of you guys had some questions. And I'm sorry, my chat is just not refreshing everything. So I'm not being able to see if you guys went ahead and got in a super chat. I do apologize for you, and especially for the 2 super chats that you guys had questions on. Just make sure you reach out to me directly, either on Facebook or on my community chat, and I will see what I can do for you. I'm not sure why my chat is it's just not connecting correctly, so I got to kind of work on the internet here at home. But otherwise, guys, I am going to retire in for the night and take a nice little extra day for tomorrow, President's Day. But otherwise, I hope you guys have a great rest of your week, and I will see you guys on the next stream next week. Cheers.